Hi, I'm Shane Mariel Agot, and today I will be presenting my machine problem tree initial value problem. So the objective of this is that it simulates biological breakdown. It uses a first-order differential equation to model how organic pollutants in wastewater break down over a period of time. It employs the Euler method to numerically predict the speed at which waste concentration drops. Specifically, it tracks down how organic waste concentration decreases over a 7-day period, starting from an initial value of 500 mg per liter. So the study I used is the numerical simulation of an organic waste decomposition in wastewater using a Euler-based ODE model. So a little background of the study is this study simulates the biological breakdown of organic pollutants in wastewater over time using a first-order differential equation. So it employs the Euler method to numerically predict how quickly waste concentration drops, which helps environmental engineers design to optimize treatment system for safer water discharge. So for the ODE system, we model how organic waste concentration decreases over time. So dW over dt is equals to negative kW, where W over time, W as a function of time, is the remaining organic waste in milligram per liter, while K is the decay rate constant. Since it is waste that is being consumed or decomposed, it is a negative sign. So IVP or initial value problem is at W is equals to 0 equals to 500 mg per liter, K is equals to 0.31 per day, and the time is 7 days. So the tool I used are ChatGPT, Google Colab, NetLogo, and Vincem. NetLogo provides a good ground view by simulating individual particles of waste. You see green and red dots in a black window. These are agents representing individual units of organic waste. Instead of just calculating a total number, the NetLogo simulates what happens to these individual particles over time. You see the specific numerical results on the slides. After 7.1 days, the waste concentration is 57.5126 mg per liter. This correlates the downward trajectory of the graph with a visual simulation. So it uses Euler's method to track waste concentration versus time. Vincem is used to model the big picture of the environment as a single system. So the diagram with the box, organic waste, and the valve decomposition rate is a stock and flow method model. It treats the 500 mg per liter of waste like a single reservoir of liquid. The math equation, d change of W over change of T equals negative KW, acts like a drain. So it highlights the systematic flow, showing how the total volume of waste in the environment decreases based on the decay constant. So it visualizes the relationship between organic waste and the decomposition rate. The resulting decay curve illustrates the concentration from 500 mg per liter down to the final concentration over the 7th day. This slide presents a high-resolution numerical trend plotted using Python. It provides a smooth exponential decay curve using discrete points calculated via the Euler method. So the graph clearly shows the concentration starting at 500 mg per liter and diminishing day by day until the 7th day. So it takes the mathematical formula and solve it in thousands of tiny steps. It starts at 500 mg per liter and calculates exactly how much is left at every micro moment. So the goal of it is it does provide a smooth, high-resolution numerical trend. This is the gold standard graph that engineers use to get exact data points for treatment system. This study concludes that regardless of the platform used, the result for organic waste decompositions are consistent. So, consistent decay curve is across Vincem, Python, and NetLogo. The data constantly illustrates a first-order exponential decay curve. So, in all simulations, the organic waste concentration starts at 500 units and diminishes to approximately 57 units over a 7-day period. So the platform-specific insight is that Vincem highlights the specific flow of the decomposition process, while Python uses the Euler method to provide a smooth, high-resolution numerical trend, and NetLogo provides a visual agents-based simulation of individual particles to correlate with the downward trajectory. So, the model validates that the rate of decay is proportional to the remaining amount of waste, which results in a rapid initial decline that gradually flattens as this waste is exhausted. That would be all. Thank you.